Hi everyone, so we're going to be looking at HL content 18.2. So let's see the expression for dissociation of water. So water will dissociate to give you H plus and OH minus, and this reaction is an endothermic reaction, which means that as the reaction goes forward, temperature is going to decrease. Now from this expression, we can deduce the Kc for this equilibrium. So here you have the Kc expression. This is a revision of the SL content. Now, because concentration of H2O is going to stay constant, so we can multiply it with Kc to have a new constant. And this is called Kw. And Kw is the ionic product of water. Now, Kw can be written as the expression of the multiplication of the concentrations of H plus and OH minus. Now, at a specific temperature, at 25 degrees Celsius, Kw has a value of 1 times 10 to the power of minus 14. Now, because this is dependent on temperature, Kw will have different values at different temperatures. So as you can see, as the temperature is increasing, the Kw value is increasing. So variation of Kw with temperature. So it changes with temperature. Now, why does it change? Here, if you look at this reaction, this is an endothermic reaction, which means that when temperature is going to increase, the equilibrium is going to shift so as to decrease the temperature. And to decrease the temperature, it will want to go in the forward direction. So when temperature increases, the equilibrium will shift towards the product side. Now, if it shifts toward product side, this is going to mean that we're going to have more products, more H plus and more OH minus. So if H plus and OH minus values increases, concentration of H plus and OH minus increases, means that the Kw value is going to increase. So this value, Kw, equals to 1 times 10 to the power minus 14. This is only at 298 Kelvin, 25 degrees Celsius. And when temperature increases, we'll have H plus and OH minus concentration increases here. Therefore, Kw value is going to go up. This is what we observe here. As you can see here, as the temperature value is increasing, the Kw value is increasing as well. Now, from the graph, at 74 degrees Celsius, the Kw value is given. Let's try to find the pH of water at this temperature. Now, because this is water here, and it's going to dissociate, we'll have an equal amount of the ions. So H plus and OH minus are going to be in equal amounts because they are in the same ratio. Remember, when we dissociate the equation, you see H plus and OH minus, they are ratio 1:1, which means that their concentration will be in the same ratio. So we can have the expression here, and because H plus and OH minus have the same value, so we'll end up with Kw equal to H plus to the square. Let's fill up the value. Here I've used value of Kw given over here. Now H plus is going to be just the square root of this. Once you have the H plus value, you can easily find the pH. pH is minus log of H plus. Complete the calculation. If you do this right, you should get the pH to be equal to 3.35. So as you can see, at 74 degrees Celsius, the pH of pure water is 6.35, which means that the pH of pure water is going to decrease at higher temperatures. This does not mean that water becomes acidic at higher temperature. but it means that the pH of neutral, the neutral pH of pure water is going to decrease with increasing temperature. So instead of having pure water at pH 7 at 25 degrees Celsius, as temperature is increasing, now the pH of that pure water is falling. But it's not becoming acidic, it's just that the neutral pH is decreasing.